Hey everybody, this is 1.4 Graphing Quadratics. We're going to just do a review from last year and then also transformations. So based off of this equation, so this is vertex form, A, H, and K are things that can shape or change the direction and the size and the location of a quadratic. So we'll do a quick review of that, what causes what, and hopefully that's not too bad for you. All right, so let's first talk about K. So look at these three examples. The left is your parent graph, means nothing's changed to it. The vertex is at the origin. Okay, in our second graph, it shows x squared plus 4. So it translates that graph up 4. It takes all those y values and moves them all up 4. And then for the third graph, it's x squared minus 3, so it moves it down 3. So what does K do? It makes a vertical shift up or down, the direction that you would expect, right? So plus 4, up 4, negative 3, down 3, okay? All right. Now let's talk about H. So H is what's inside that parenthesis for vertex form. When you look at that, you might say, well, that looks kind of weird. Like, why is it on this middle graph, why is it positive 5 instead of negative 5? Well, first off, kind of think about the form. It's x minus h. So if h is 5, like right 5, it moves it right 5, it's going to look like it's a negative 5. If h is negative 3, then when we do the equation, we're going to do x subtract negative 3, which will give us a positive 3. So that's kind of one of the things. Another thing that you could kind of look at it is when like these points, these vertex are at the x-axis, right? So that means on these problems, the y value should be 0. So if you were to set y equal to be 0, well, the only thing that's going to make this be 0 is if x here is 5. So here x is 5. For this example, the last graph, it would have to be negative 3, which, what do you see? It moves it negative 3. So you could kind of also think about that as well if you think that kind of makes sense, okay? It's the one that's kind of tricky. So it's always the opposite direction. So it's a horizontal shift. It moves it left or right. But in the equation, it looks to be like it's the opposite sign. Okay? You can think of it like that if you'd like. All right, next we have is when a is negative 1. So here a is negative 1. What does it do to the graph? It reflects it over the x-axis. Okay? Kind of a cool thing if you want to think about it. It won't make a lot of sense in like quadratics, but if you have the negative inside the parenthesis, this makes it reflect over the y-axis. But like for a quadratic, it doesn't really matter because quadratics are symmetric. But when we get to maybe some other types of equations, you'll be able to see that. Okay. So yeah, we have a reflect over the x-axis. All right, and then our last thing we're going to talk about the value of a. So if a is 1, there's no change in the graph. But if a is 3, it takes all of those y values and triples those. So it grows 3 times as fast. It makes it look a lot skinnier, and we say that's vertically stretched. And if a is less than 1, so here it's a half, it grows half as fast. So it becomes more wide, and that's called compressed. Okay, so it's either vertically stretched or compressed. I should have had this here, so vertically. Okay, You can also vertically or horizontally stretch, but we'll probably get into that later, not for quadratics, okay? All right, so that's what they do. So A can reflect it over the x-axis. It also stretches and compresses. H moves it left or right. K moves it up or down. And I think that was it. So let's, I didn't release, I didn't clear this out, okay? So let's go and we'll do these again, but, all right, so here I'm going to ask you to describe the transformations using words, kind of like reflect or stretch or compress, translate left or right, up or down, okay? So always just maybe start left to right. See anything that's different from the parent graph. So the parent graph would be y equals x squared. So anything that's different, we're going to talk about. So first thing we see is this 4. So this is vertically stretched. Why? Because it's 4 is greater than 1. Okay, and we could say by a factor of 4. All right. Next thing that's maybe a little different is this -3. But again, it's the opposite of what you would think. So you would think negative would be going this direction, but it's actually going to go right. Okay, so we'll say right 3. And then our last thing is this -1. It's going to be down 1. Okay, let's try a couple more. So first thing we see is this negative, so that means it's reflected. Reflected over x-axis. Okay, I guess we could look at C as well. That's also reflected over the x-axis. So I'm just going to copy that over here. Okay, so both of these are reflected over the x-axis. On B, the first thing we see next, or the next thing would be this 2. Again, it's the opposite direction of what you'd think, so it's going to be right 2. And then up 3. For C, the next thing we see after the negative is the 2. So that means, actually what I did in class is I changed this. So why don't do that? Okay, let's make it be 1/2, just so we have an example of that. So the next thing we had is a 1/2, so that's actually vertically compressed by a factor of 1/2. And then our last thing here is this +3, which means it's going left 3. All right, so hopefully you're okay with that. Just because I feel like this makes more sense is we are going to go to these examples. This is kind of going the opposite direction. So these are the transformations, and we want to write the equation. So it's kind of the same sort of thing. So we'll maybe write down our equation, and we'll just go line by line, adding the things that we need. So vertically stretched by a factor of 2, well, that's just our A. So we'll write that down. Next off would be our H. Let's see if we can find our H. So right here, horizontally, so that's left and right, it says that it's translated 3 to the left. So again, you would think that left would be negative. So that would H would be -3, but when we plug it into the equation, it's going to be its opposite because it's x minus h. Okay, and then k here, it's going up, so k is 4, so +4. All right, let's try another one. So vertically stretched by a factor of 5/2, and it's reflected. So that means that y is equal to -5/3. So that's our A. And then we'll write the rest. Horizontal is going right. 3. So right, h is 3. But again, when we plug it in, it's going to be the opposite sign. And then it's going down, down 4, so negative 4. Okay, let's just try a couple. If you feel like you're okay, that's probably good enough, but I'll just finish this up. So here we've got a quadratic. It's reflected over the x-axis, so y equals negative. And then it's going left 2, so h here is negative 2. But again, it's going to be its opposite sign when we plug that in. And then it's going down 1, so k is negative 1. And then our last example, it's compressed, so y equals 1/2. X is going right, so h is positive 1, but when we plug it into the equation, it will be its opposite, and then it's going down 3. So there's some good examples. All right, now let's go and talk about graphing. Hopefully this one's not too bad. If you remember, in vertex form, you can easily find your vertex. Just got to remember that just like when we plugged in our h, it changed its sign. When we take it out, it's going to be negative 4, negative 3. So k stays, same sign, and then maybe I'll just say same sign for k. Okay. But then h changes, okay? So then we'll plot that, so negative 4, negative 3. And then we got to figure out what's our pattern. So if you remember for a quadratic, it's always a times 1, 3, 5. So for this example, a is negative 2. So when we multiply negative 2 by 1, 3, 5, we're going to end up getting negative 2, negative 6, negative 10. So we'll go from that vertex, over 1, down 2, over 1, down 6. Sorry, that's out of the graph. I'll fix that next year. Okay, and we're good. Let's try a couple more. Vertex here is negative 4, negative 4. So that would be like right here. And now it's going up 1/2 times 1, 3, 5. So we end up getting 0.5, 1.5, and 2.5. And we could keep going with that pattern, but we're just going to stick with the 1, 3, 5. So we'll plot those on both sides. Connect your dots. That was a little weird. There we go. And we're good. All right, let's try these last two. Our vertex would be negative 3, negative 3. And the pattern is negative 1 was our A times 1, 3, 5. So it's going to go down 1, 3, 5 on both sides. And the 5 doesn't fit, so we're just going to stop after the 1, 3. Last example, vertex 4, comma, negative 2. So 4, negative 2, I think is right there. And then it's that pattern that we had for A. It's 2, 6, 10 going up this time. So 2, 6, 2, 6, connect your dots. Okay. Make sure you read the instructions when you do your homework. Some of the problems is it will just ask you to put 5 points. So this would be done for some of your problems. So make sure you read. I had people do 7 points on some of them, and it would take points off because they did 7 points instead of 5 points. So only do those 5 points. Sometimes, let's see, I think there's one coming up right here. Sometimes your problems will look like this. You're going to need to choose this option. So it does not want you to do any points. So you'll need to use that. So let's just do this example. So we would need to find the vertex. So the vertex here is negative 1, 2. And so when you choose this option, then you'll push that vertex at negative 1, 2, which is right here. And then you just need to push our point, put one more point on that graph. So we know our pattern here is down 1, 3, 5. So we just need to go over 1, down 1, and that will make the rest of the graph. You won't need to do any other points. Okay? So sometimes it'll be like that. Sometimes it will be like this, where you'll put the 5 points, and that's it. Okay? You'll have something like this. I don't think you need help with that, but you're just going to select the options. Make sure you write down the ordered pair for the vertex. So for here, this would be what? Negative 4, comma 1 with parentheses, right? Okay? And this is a little different. It says opening, so this one opens down or up instead of saying reflected. Okay? And then this last one, you probably really want to make sure you pay attention here. This one's a little different. It gives you the equation for this graph. But then it says, what would the h and k be if the parabola was shifted 4 units to the right? So 4 units, this would be this way, 4. And then down 4. So our vertex would now be at this location, and it would look something like this. And they want us to write those down, that point, 0, negative 5, and then write the new equation using the new h and k. So we need to know what a is. Looking at the graph, it looks a little maybe hard to find, but if you look at the original equation up at the top, a is negative 1/4, and that hasn't been changed, so we're going to use that. So it would be y, I guess not y, we already have the equal sign, would have what, negative 1/4, and then x minus 0, but x minus 0 is just x, and then minus 5. So for this example, that's what you would type in. Okay? All right, well, let me know if you have any other questions. We'll see you later.